Welcome back to the anatomy of a Minecraft model, lecture number 4, modeling software. Before the break we took a look on Techni, how we could design Minecraft models there. Techni is obviously designed to work with Minecraft, so we export the Minecraft models directly, or well, we get the code for the Minecraft models rather. But now I'm going to take a look on how we can work with any modeling software that is not specifically designed for Minecraft, that can do one specific thing. We have one requirement. It should be able to export that as a .obj file, object file, and if it does that, then we can import that using Forge, but we'll take a look on that in just a second. So if I go in here, I'm currently looking at a very simple model here, well, in Blender. Blender is a free 3D modeling software. You can do a lot of more things in it as well, but what we have here is just a simple block here, but we have cut off the top like this. I'm not going to teach you how to create things with Blender. I'm in no position of doing that. I'm no expert. I've done something in a few years ago, but I had to revive those skills to make this little thing here. And we're just going to use this, and I'm going to show you how to import that. If you want to learn about 3D modeling, then I suggest you googling and finding a good tutorial for that specific software. There's nothing special with us using Blender, it's just that I chose to use it because I've used it before and it's free. So what we need here is the model part there, but we also need something called a UV map, and that's basically going to tell us where all the things are. And by all the things I mean the texture, so where like one side is. So this part here is we can actually take a look. So I'm going to, where's that one? There you go. So if I select that one, so if I select this face here, this side here, it shows us that this is the texture there. If I select that one, we see that that's the top. If I select that one, we see that that's the texture there. The bottom is defined over there, and the back there is over there. So all of those together creates the UV map there. And now I can just select them all like so. It's probably a shortcut for this. There you go. So that's what we have here. When we have that, whatever you want to have it, you need to create a UV map. The model itself, depending on your 3D modeling software, it's probably going to look different, but in the end what you want to do is go to export and then export it .ob there, and that's exactly what we're going to do. And then the next part is obviously to import it again, but we also need a texture, right? And this is just a UV map that tells us where we should put the texture. And of course I prepared all of these things already. So if we head over here and head into example, I put it into, by the way, here's the bomb.ob. So the model I have here in Blender, that's going to be the spreading bomb that the falling bomb creates. If you saw that when the bomb reached the ground, it starts to spread, and that's just using a normal block rendering. We just gave it some icons and so on, and that's exactly what we're going to replace with this thing here. It doesn't really too much sense, but that bomb is called a weird bomb after all, so it doesn't really matter. So I'm going to head over here. Here's where I stored it. So if we open that one, you can see it in small there already, but if we go here and zoom in, we can see that what we have is exactly like we defined by the UV map. So we have the sides here, we have the top there, the front, the bottom and the back, and so on. So we need a texture and we need a block there with the UV map, but obviously we'll have to create those ourselves in some other softwares. So what I'm going to show you is how we import these things when we have the texture and we have the object, the model itself, and the rest you will have to learn elsewhere depending on which software you want to use. So let's go back to Eclipse. There you go. So what we want to do is create something that renders this. You might also realize that we're going to try to render a model, right? We're going to render a model for a block, and that's totally possible. We don't have to import it to be able to do that, so you can actually work with models for blocks, and to do so we need a tile entity, but luckily for us the bomb there already has a tile entity. But what we want to create is the rendering code. So new class here, I'm going to call it render block. Render bomb block, like that. So we have render bomb already, but now we have one for the block itself. Extends tile entity special renderer, like so. And this is, for instance, what the chest uses when you open the lid and so on. But you shouldn't use this if you don't have to, because it's usually better to, for instance, when we have a furnace, we just have different icons on the different sides. So that's just a normal block. There's no reason to do something else with the model. For instance, when we have a staircase, that's just well, different blocks put together, so therefore we don't have to bother with the model. But for instance, when we have the chest, we want to rotate and open the lid and so on, so therefore that's a model there, and that's when we use tile entity special renderer, and we'll see exactly how that works. We need to implement one method here, and that's the render tile entity add. We get the tile entity, we get the X, we get the Y, we get the C, and finally the partial tick time. So it's a bit like the other rendering codes. If we take a look in render bomb here, we have one do render part here, we have a location, and we have a partial tick time as well. But instead of an entity, we have a tile entity, and we're going to do a few similar things. A model. We need a model, right? So what I want to do here is do private iModel custom. So we don't really have to create a model ourselves. We have already created that through, for instance, Blender, like so. So what we want to do is just import it, and therefore we can just use this iModel custom here, just import that. And then the important part is to use something called the advanced model loader, which is a part of Forge. So it's a fairly new thing in Forge. It hasn't been there for too long. It's been there for a few months, I guess. Render, where is it? Bomb block, there you go. So that helps us along. We don't have to bother about it ourselves. We can just use the advanced model loader through Forge. So we do model equals advanced model loader, like so, and simply do load model and give it the resource here. Assets, example, models, and then bomb.obj, like that. And that's exactly where I put it. If we take a look, if I open the models here and go back to textures, go back to example, and here we have models, sounds, and textures, and obviously it's the models we want, and there it is. So it is in, if we take a look up here, assets, example, models, bomb.obj, and that's exactly what I put here. So that's the only thing we'll have to do. When we have the object files through like Blender or Maya or whatnot, then we save it and then we load it using the advanced model loader, and that will take care of everything for us. However, we have a few restrictions. I don't know exactly what the restrictions are, but if you take a look on these faces here, each face of this model here has 4 vertices, 4 corners, like that. It has to have 4 corners. We can't, for instance, do a cylinder like so, like that. At the top here, the face at the top have a ton of faces. Can you go away, the other one? Delete. Alright, I deleted both. But if we add a cylinder here, the one at the top has a ton of vertices to sort of create a circle shape here. And the same thing goes if we add a sphere here. At the very top of the sphere we will have, if I go into edit mode again, if I can, how do I do that? There you go. So as you can see, I'm not an expert. If we zoom in here, I don't know if you can see it. Let's go into a bigger view, and I did something weird up there. As you can see, oops. Yeah, like I said, I'm not entitled to teach about this part here, but what we have faces with just 3 vertices, these triangles here. And when it comes to the advanced model loader, we have to have vertices, well, 4 vertices per face, otherwise it will fail to load it. I don't know, like I said, I don't know exactly what the restrictions are, but that's one extra restriction that I know of. So if you have a sphere, you will have to make sure that all of the faces still have 4 vertices, otherwise it won't work. Okay, so now when we have the model, just simply load it like that. It's just a matter of writing the rendering code, and we've done this so many times before, and it's fairly similar. It's not exactly the same, but it's fairly similar. We start with the GL push matrix, and we end it with GL11.GL pop matrix, like that. Then we want to translate it, so we will put it in the correct location, GL.GL translate F, and float X But here we should add 0.5. Yes, because here we have a tile entity, and therefore we should move it so it's centered properly. If we have an alright, let's just zoom in here. If we have the entity if we have an entity, we get a specific coordinate of the center already. Here we just get the coordinate of the correct block. So I'm not entirely sure why it's a double, but what we want to do is simply increase it by 0.5 here in each dimension. Float y plus 0.5 float like that, c plus 0.5 like that. So that's what we want to do first. So just the translation, we've done that before. We can take a look in render bomb here. We does it similarly here. We don't do it exactly the same. Here we don't add 0.5 for instance. Then we need to do the scaling, but here we have to make sure that all the dimensions are aligned properly. We don't have to bother about that here, but what we want to do is make it a bit smaller, and the reason why is because the model we get from the advanced model loader is a bit too big. It might depend a bit on your model and how you want it to look, but what we want to do is simply scale it and give it just half the size. So it's very simple, like just like that. There you go. So there we go. Now we have done the translation and the scaling. What do we have left? Well, we have the texture left and actually rendering the model. And these are fairly simple as well. The texture, we've seen that before. It's private. Private static final resource location, like that. Texture equals new resource. Well, it's fairly simple if you can spell, that is. So we go resource location like that, and I'm going to give it example with a lowercase e. Thank you very much. And finally, where it is located. So textures, models, bombs, bomb underscore block, sorry, like that, dot png. So nothing new there, and then it's just of binding this. But when we saw it in render bomb here, we could just use this method here and return it like so. But what we'll have to do is the same thing that we do with item renderers, the same thing we do with interfaces, and that's actually to bind it manually by doing Minecraft dot get Minecraft dot func and the one with the capital K there. So yes, these are still unnamed here. What I want to do is the 1577A there. So what we do is we get the rendering handler and then we bind the texture like so. There you go. Okay, and then we want to render the model. How do we do that? Well, it's very simple. We just ask the model to render all. There you go. Boom. So if you have another model, for instance, when you make the chest, maybe you make a Minecraft model that you want to be rendered, then it's just a matter of rendering here in its own way. The reason why we do model.render_all here is because we get the model from the advanced model loader like so. And for instance, if we want to get a model from Blender or Maya or 3ds Max and so on, when we work with entities, then we could just do it here. We do model.render_all there instead. So as you can see, we have two render codes here depending on if it's an entity or a tile entity, which is fairly different. Not too different, but a bit. But then we come to when we render the model, and there it's just different depending on the type of model we have. So in the case of the bomb here, we have a normal Minecraft model, and therefore we do it like that. We have a model bomb like so, extending model base, and here we just have a model custom where we do model.render_all like that. So we just mix and match those things. So if we wanted a advanced, model that we got from the advanced model loader, when we rendered the render bomb thingy, the falling bomb there, we could totally do that, but that's not what we're going to do now. So that's pretty much it. Let's take a look what we can do next. I was just about to say let's take a look on that in the game, but that's of course not the case. Now we made the rendering code, but we of course need to bind that. So what we want to do is head over to the client proxy, and here we want to refer to client registry dot bind. There it is. Bind tile entity special renderer like so, and we give it two things. We give it the tile entity class, and luckily for us, we already have a tile entity bomb for that block there. If we wouldn't have that already, we would have to create one there. So it has to have a tile entity to refer to. That's the one controlling the rendering after all. And if we wanted to animate things like when the lid of the chest opens and so on, we can just animate that through the tile entity, and then when we that's the wrong thing. Here we go. Then when we rendered it, we would just apply some rotations to it from the tile entity there. Here you go, new render bomb block like so. And we need to do one last thing. We have registered this for the tile entity, that's cool, and we have the rendering code, but we need to actually tell the block itself that it should be rendered by its tile entity and not rendered by itself. And that's an important part, otherwise both will try to render it, and that's going to be very weird. You will have the old animation, well, the old look and the new look at the same position, which is not well, if you want to have something messy, then do so, but no, don't really. So what we want to do is head over to the block bomb here and override 3 methods. We need to override the render as normal block. We should return false here. Oops. Return false. We should do the is opaque cube, and the reason why is because it's not well, a full cube anymore. I've cut off a part. If we take a look on the model, no, I don't have it there anymore, sorry, but you know, you remember the one I had. Return false. And finally we'll to get render type, but what should we return here? When we worked with block last time, what we did was just return the ID of what we wanted, really. So if we had it rendered with ID 300, then we would return 300 here, and so on. But here we can just return -1, and that means that we're not going to render it here, and that means that the tile entity will be able to render it without the block bothering it about it and rendering it there at the same time. So there we go. We just override these 3 methods here. We in the client proxy we do this thing here, bind tile entity special renderer, and then we have a tile entity special render here that renders it for us. And if we wanted to load an object file as our model, then we just use the advanced model loader and loaded it like that using the path there, and finally did model.render all when we wanted to render that. So let's take a look now when we have registered it properly. Here we go. And what we want to go and do is head over to block, I think. Yeah, there it is. And as you can see, the icon is now messed up. We'll take a look at that in just a second. But now if I place it, ooh, there we go. Sweet. So we have this model here, and it all explodes. But as you can see, it's not using another texture when it's, well, idle like we had before, because obviously we haven't specified that, and that's the next step I'm going to do. If we head over to the textures here, we can take a look at the textures models, and we have that one. But I've also prepared an idle one, which basically has a changed color for everything that's red. Everything that's not red is still using the same. And if you didn't take course 3, what we had was basically that when a bomb spreads, it is done and just waits to explode. But when it has done that, we indicate that by using a texture with not as much red in it, not the same saturation there. And that's exactly what we're going to do now. Use this bomb block idle otherwise. And it's fairly simple. There's no rocket science here. So what we want to do is simply private static final resource location texture. We can call it texture idle like so, equals new resource location example textures models bomb block idle.png like that. There you go. So now we'll load another one, and then we can just bind the one we want. How do we define that? Well, the idle state, if it was idle or not, we got that from the metadata, so it would be synchronized properly. So we can just ask the tile entity about the metadata. That's totally fine. So tile entity.get block metadata, and if that equals to 0, then that means that it's still active. Textures, I'm using the normal texture. Otherwise, I'm going to use the texture idle. Like that. Like I said, no rocket science. Let's take a look. like that. And now if I place it, we can see that when it has spread, the inner ones are changing to the outer texture, and then everything is going to be like that. So as we can see, it renders it properly, but we still have one thing left to do, and well, you might take a look in what I have in my hand. It's still the weird bombas icon, the top icon there, it's not rendered properly, and that's the same thing when we rendered the blocks with the where is that one? I think it's in Redstone here. Yeah, the silly machine. We had to manually tell it to render in 3D like that again. But if we head over to Tile Entity Special Renderer, wherever that is. Oh, well, I mean it already. That's why I'm so confused. And then we click on Open Declaration here. Just to check that superclass there. There's nothing here for us to, you know, define how we render it in the texture, well, in the inventory, so we can't do that directly there. But what we'll have to do, well, we should know this part. Now we have a quiz for 3 seconds while I create that class. What should I do? So here we go, new class, and what I want is obviously a item renderer. So render bomb block item, very silly name. So now we have render bomb, we have render bomb block, and we have render bomb block item, and this is obviously going to implement item renderer, implements item renderer, and it's going to work in a similar way that we did with the droid. And we saw when we worked with the droid, it was very easy because we just had a model, and then we would just render that model as part of the item as well. And since we have a model, we can just, you know, render it here as well. So I'm just always going to render it, and I'm going to use all the effects, so these two can return true, like that. But then I have to define the rendering code there. But I'm going to do it in a similar way. I just want one model. There's no reason to load it twice from the file. It's even more, well, it's even better now. Now it has to load the object file, and that can be very advanced. So there can be a ton of things there that Forge will have to load for us. So there's no reason to load it twice, like one time for the item and one time for the you know, the actual block or the entity or whatnot. So what we will do is just have a constructor here, public render bomb block item, and I want to spell that like so. And what we want to do is just ask for the iModel custom model, and then that's the one we're going to render. This private iModel custom model like that. There you go. This dot model equal model like this, and I'm going to do a similar thing back in the render bomb block, so we can ask for it here as well. So what I'm going to do is just remove that for now and do this dot model equals model, and then ask for it here as a parameter. I forget the L. I model custom like that. Client proxy. So we're going to create it here, and then both of them can get access to it. So I custom, it's called iModel custom, not the other way around. Model bomb like that, and we can just load it here. Just copy that part. Alright, I copied the whole part. There you go. Import those things, and there you go. And then it's just a matter of giving it the bomb there, and then when we register the other thing, which we should do in the same way we did for the droid, this part here, we're just going to give it the model there as well. So Minecraft Forge client dot register item renderer. The renderer here should be new render bomb block item like so, and then the model bomb like that. There we go. Import it, and boom. But what should the ID be? Well, here we use item info.droidid plus 256, but here for the block we can simply do block info dot bomb ID like so, and that's going to tell us, well, tell the game that we're controlling how this block should be looking like in the hand of the player, or in the inventory, or dropped on the ground and whatnot. There you go. So now we give both of them the model and we register both of them, but obviously we are not rendering anything just yet. This render code here is empty. But it's fairly simple. We've seen things like these before. So what do we do? Well, gl11.gl push matrix, like before. In the end, what do we do? Well, gl11.gl pop matrix, like that. Then inside here, what we want to do is scale it a bit, and then bind the texture, and finally do the rendering. So what I want to do is gl11, and I'm going to do the same scaling here, just to make it smaller. It's too big. 0.5, 0.5, 0.5, like so. Then we want to bind the texture, which is just Minecraft dot get Minecraft dot, and then the one that ends with a capital K. That's how I remember it. These will obviously be named later, like get rendering handler, and then bind texture, or bind resource maybe. Render bomb block dot texture. So I'm going to get it from the well, when we render the block there, but we can't access that because it's private. But I think it's, well, it's a good reason to just make it public. There we go. So it's going to load this one here, the normal one, and then we can use that for rendering the block in the inventory. There's no real reason to use the idle one. You will always only be able to place the active one there, so it's fairly simple. So what I want to do now is head over here. We have bind that part, and the last part is model dot render all. Boom, done. There we go. Let's take a look. So what we can see here is that we put a lot of things together. We have the Talent special render, so that's a new thing, that how we render things with Talent. We have taken a look on the advanced model loader, so how we can through Forge load models from other programs like Blender and 3ds Max and so on. And then we are also using something we have used before, which is the item renderer that tells us how we can render a specific item in of the player and so on. There you go. Look at that. In my inventory it looks good. In my hand it looks terrible, and in my hand like that it also looks kind of terrible. But well, in the inventory it looks fine. So that's good. That's a good start. So what we will have to do is modify the rendering a tiny bit there, depending on the type. So what I want to do is simply, like we've done before, switch type. But as you might have seen, it wasn't the same issues that we had when we rendered the droid. They didn't have the exact same locations. The item, for instance, looks perfectly fine. I'm not going to do anything with it. But the equipped one and the equipped one in 3D, I'll have to do something with. So this is the equipped one in 3D. And what I want to do here is translate it. So we just move it a bit to get closer to the hand. It was very far away. GL translate, and I just checked what looks good is 0.4f, 1f, and 0.6f. We just move it down a bit. That's that one. We move it sideways. I think that's that one. I can't remember. One is sideways and one is closer to the hand. I can't remember which one is which. I think this one is closer to the hand and this is sideways, but I'm not entirely sure. It can be the opposite. I just tried that; those were fairly good. And then we do equipped first person like so. And do break there, and then we can have the default here at the end. For the other ones, we don't want to do anything there. GL11 GL translate F like so. We don't want to move there, but we want to move it up and to the side to make it fit properly like this. So depending on the model you have, depending on the item you have, you might have to tweak these values depending on where you want it to be to fit your hand properly, because they might be a bit off compared to normal items and so on. So it's a bit of tweaking there to make it look good. But one more thing that I want to do, when we hold it in first person, we're going to see the back, and normally that doesn't really matter. We had that for the droid itself as well, but when we look at the back of this block here, what we'll see is the big red back side of everything. It would be nicer to see the front, so we could see TNT there on the top. So what I want to do is just rotate it 180 degrees to make it well, rendered in the well, facing the player basically. It's going to do that already when it's equipped, so I don't know exactly why they are rendered differently by default, but that's just how it is. Maybe it is to make it look good with sorts and so on. I don't have a clue really, but what we want to do is just rotate it there as well to make it look good. And there you go. I can hold it in the hand like that, and I think I messed up a bit. It looks very weird. So that's not really how it should look like, but at least we can see it now. But what I did was to not rotate it properly. We need to tell it which dimension to rotate in, obviously, and that's why it didn't really understand what we were working with, and everything just went wrong. But what I want to do is just rotate it 180 degrees so we can look at it. So that's why I want to rotate it in Y, so we can the front instead of the back. If you would like to see the top instead of the bottom, or the left instead of the right, then we would have to use the other dimensions, but we want to use Y there, and that's exactly what I'm doing here, but I messed it up a bit, sorry about that. So there we go, now it looks good. So we can see the front there, just like so, and we can see it there when it's dropped, like that. We can pick it up, see it in the inventory, we can see it in 3D, and of course it's rendered as a part of the block as well. So there we go! Pretty nice! A very good end to this course, I think. So we have seen how we can work with the advanced model loader, sorry, that's what it's called, advanced model loader, to load .ob files. We've also seen how we can work with models for tile entities, and we've seen another example of when we can use the item renderer, this time for blocks. But before we end this, I want to go through what we've done today, a summary of the code and the different paths there, not just what we did recently. So here we go. So we started with Techni, a pretty good 3D modeling software specifically designed for Minecraft, so that part is quite nice. We have the main view there, we have the texture at the top there, so it's going to generate the texture sheet for us. We just need to give it the texture offsets properly. In the bottom right we have the model tree, so there we can see the different boxes that we have, and in the top left we have the box properties, where we can set the properties of a specific box. And the good thing about Techni compared to like Blender and things like that is that everything we've learned with the models in Minecraft, like all normal models that we have, is going to be applied to Techni as well, because Techni is made to mimic Minecraft, and also when we have a finished model in Techni we can just hit export and get a Java code for it, and then we can code in some changes there. But we've also seen that some things might differ a bit, and we'll also seen that we can't really do animations too well, yes, because we can't do child models there, but it's very nice. We can see directly what we're going to get when we add it together like so, and it's going to generate a texture sheet for us, so it's very easy to just add a texture there on top. We don't have to think as much. We can be a bit lazy there. But if you want to, you can still do the models manually. That's how I personally think, I'm doing it. I like it that way, but you can totally use Techni. It's quite nice there, but as we also saw, we had some tiny mistakes there, which hopefully is just a bug that might be fixed later there, but we could fix that just because we had a knowledge of how the models worked in the first place, like this. So what we did was just change the rotation order, and this is not just because Techni messed up with what the model we had, but you can do this in some other cases. It's quite important in some cases to force it to rotate it in another order, because if we rotate one angle and then rotate the next angle in another dimension, then that's going to be affected by what we rotated in the first place, and maybe we want to force it to rotate it in another order, and to do so we can do it something like this. We create two model renderers. One's called rotation helper, and one the normal model renderer. In this case it was called leg, that was automatically generated by Techni. That's why it has an uppercase L there. And to the leg, the main part there, we add the actual box we want to render. Then we add the leg as a child to the rotation helper. So the rotation helper is going to help the leg to rotate there. And then what we want to do is, if we want to move the rotation handler, or well, if we want to move the object here itself, the leg, then we want to set the rotation point for the rotation helper instead. And this makes sure that the rotation helper does the movement, but then the leg will be at 0, 0, 0, which means that the leg will will be wherever the rotation helper is. So the leg will obviously move when we move the rotation helper, but it won't rotate around the rotation helper's position, so it's going to be at the same position, and therefore when we rotate the rotation helper, it's basically going to make sure that the leg there is rotating around itself like it would be doing if we didn't have the rotation helper at all. And the reason why we have this is, of course, so we can set the rotation for the rotation helper for those rotations we want to start with. So here I'm starting with Y, and then I'm leaving the X and Z rotations for the leg itself. This allows us to force it to make the Y rotation first, then the Z rotation, and then the X rotation, compared to the normal order, which is always C, Y, and X in that order, and therefore we'll do it like this. So this is a bit of a trick that you can do to make sure that it rotates in the order you want to, which might come in handy in some instances, or for instance if Technic messes up, but it's quite nice to be able to do so, because you can't just tell it do it in this order. It doesn't matter which order you set it, it's when it's rendering it in the end where it matters. Right, then we got to Blender, or well, basically any 3D rendering software, and what we want to do is make a model here. We can see in the main view that little model that I made there, and we also need a UV map, which is basically going to tell us where the different textures will be located. And then it's just a matter of making a texture that fits that one. So we have two textures here that have the textures in the proper location to fit the UV map, like so. If we take a closer look, I don't think all the faces were selected there in that UV map. We can actually see that it's a black box there where we actually have a side, but that doesn't really matter. So we have those two textures, they fit in the UV map, and therefore we can start putting those things together and render them in Minecraft. And what we want to do is have a tile entity special renderer if we want to render this as a part of a block. So here we also see the new thing about a tile entity special renderer, which we can use even for other models. For instance, the vanilla chest is using a tile entity special renderer to be able to render this properly, or well, it uses things like that at least. But if we want to work with .ob files for a tile entity, or for any other model, for an item, for an entity, then what we want to do is do model equals advanced model loader .load model, and then just give it the ob file like that. Pretty straightforward. And when we want to render a tile entity, what we do is just we override the method render tile entity at, and then it's just a matter of render that. But then when it comes to the actual model, the model we get from the advanced model loader, when we want to render that, we just do model.render all, but we will have to scale it a bit, move it a bit, and bind the textures and so on. But we've seen that multiple times before. And then when we work with the tile entity special renderer, we'll have to tell the block to not render by returning -1 as the render type. We set the isopile cube to false, so we'll make sure that the other sides render properly, and we also tell it that it's not a normal block anymore, like that. And here we go, here we have the registration part that we had in the end, and in the end we actually did the advanced model loader.load model code in the client proxy, so we can see here that we have that there as well, even though we had it in the previous slides as well. And what we want to do now is just do Minecraft Forge client register item renderer for the item, and client registry.bind tile entity special renderer for the tile entity. So what we have seen here is a mix-up of a few different things. We're using the advanced model loader to load a model, and we have seen the tile entity special renderer to render tile entities for blocks, so we can have models there, and then we just merge them together to be able to render models from Blender, from 3ds Max or whatever, as a block, rather than using the normal simple block renderer, or even more simple, the very basic icon setup. So if you can, you just use the icons. If that's not enough, add your own modeling code. Maybe you want to make a staircase, a table, or a chair or something like that. If that's not enough, then you can load models, well, then you can make models in Minecraft. If that's not enough, then you can load them using the advanced model loader and get a model from an exported modeler from a 3D modeling software. But that's pretty much it. Don't forget the questions and exercises document. Answers to the questions are of course in the end, and possible solutions as well. Questions to practice, well, no, that's the exercises. Questions to see if you've learned it, and exercises to practice, and further exploration to continue on there. But this is also the last lecture of the course, which means there will also be an assignment ready. So it's just about code that, hand in the mod to me. So you're supposed to make a simple well, two simple models, one for a block and one for an entity, and then you make those, you send it in to me. If everything is all right, I mark it as correct and you'll pass the course. If that's not correct, I'll send it back and say, alright, you did something wrong here, and I'm not going to send it back just because it's ugly. If it follows the requirements, then you're done. This is not a art class after all. And then you can just hand it in again, and I'll give you a new mark. Then you can just hand it in again and again until you have done all the requirements properly, and then you will pass the course, and that's pretty awesome. So this has been the anatomy of a Minecraft model, lecture number 4, modeling software. I've been VSWE, but this has also been the anatomy of a Minecraft model, so the whole course, the anatomy of a Minecraft model. I hope you learned a lot about modeling, how we can apply texture to that, how we can animate things, make blocks render, make tile entities render, load out from different softwares, and so on. And if you're interested, the next course will be about bits and pieces, so that's about binary, hexadecimal, how we can compress data into smaller values. So instead of sending a lot of data, we can maybe send just a few bytes rather than 49 booleans. That's what we had in the last course, and so on. So that's the bits and pieces course. I'll see you then if you take that. Goodbye.